We're watching the lesson on wheel and axles. In this lesson, we'll be talking about another set of simple machines. This one is called the wheel and axle. Previously, we talked about the lever, and now we're going to talk about the wheel and axle. And you may notice as we finish this lesson that they're actually very similar. So, what is a wheel and axle? It's a type of simple machine. And these are seen everywhere. You see them every day of your life all the time, and they're one of the most common machines used. It is when two round objects, are attached to each other at their centers. The turning of one turns the other. So the large one here is our wheel, and the small one is called our axle. And so if you turn one, the other one will turn. That's it. So where do we see wheels and axles? Well, we have Ferris wheels, bicycles, doorknobs, pencil sharpeners, right? For example, the doorknob, when you apply the effort, when you turn the knob, right, you're turning the wheel, and the smaller part is the axle. So why does a wheel and axle make things easier? Well, this simple machine makes work easier by using the larger circumference of the wheel to turn the small axle, right? So if you wanted to move something easier, you would turn the large wheel, and that would turn the small axle that's attached to the load. So you would turn this large wheel around, and this would make it easier to move or spin whatever's attached to this axle, because you have a larger distance to move. You have a larger distance to move than the small axle. So again, just like with levers, you have this larger distance, so you need less force, right? You're not spinning on the axle, you're spinning on the wheel. You are turning the wheel. So that makes it easier for you to turn or lift or move the object. Wheel and axles work in the same way levers do, right? The larger wheel portion moves a larger distance than the axle, because again, this has to move all the way around. If this was our handle, and we were turning this all the way around, it would have to move all the way around. While the small axle only has to do this. So you have a larger distance to move through, so you only need less force. Same with a lever. When you're trying to lift a heavy load, the large effort arm allows you to use only a little bit of effort force to lift this heavy load. So the larger your effort arm, the less force you need. The larger the wheel, the less force you need to move whatever's attached to the axle. And you can even turn a lever into a wheel and axle. You can look here. You have your fulcrum, your load arm, and your effort arm. Well, if instead of the effort arm going up and down, it went all the way around, well, that's just like a big wheel, spinning the load arm going all the way around. And the load arm is smaller, so you have a smaller wheel, or axle. So wheels and axles work in the same way levers do. And this video will help elucidate that more. It shows good animations about how levers and wheels and axles are the same. So this type of technology has been used for centuries, for thousands of years. When people wanted to bring ore or iron, steel, things like that from the ground, or even water, they needed to use a wheel and axle to lift it up. So even though this doesn't look like a wheel, you can see that this handle moves all the way around in a large circle, right? So that's your wheel as it moves all the way around. And you have your axle here spinning a smaller amount. So it's easier to lift this load, bucket of water or whatever, as you are spinning this wheel a larger distance every time you turn it. So if a wheel and axle works like a lever, then it must also have mechanical advantage. Well, how do we calculate mechanical advantage again? Right? How do we calculate mechanical advantage in levers? Well, it's effort arm over load arm. Right? If I don't give you the forces involved, you can use the measurement of the effort arm over the load arm. The other way is load force over effort force. Right? Hopefully you remember that. It's upside down in force instead. But here we have effort arm over load arm. So how can we use this calculation of effort arm and load arm to find the mechanical advantage of a wheel and axle? Well, the mechanical advantage of a wheel and axle is the radius of the wheel divided by the radius of the axle, right? Remember, this is where you're applying your effort, and this is a larger distance. So this would be your effort. This would be your effort arm, right? Well, this is where the load is attached, and it's moving a smaller distance. And this would be your load arm, or the radius of the wheel over the radius of the axle. And that shows you how a wheel and axle is the same as a lever. It just goes in a circle rather than up and down. So what is the mechanical advantage of this winch? So pause the video and see if you can solve it. Okay, hopefully you paused it, solved it. We're going to work through it. So this part is where we put the effort, right? We're spinning this around to lift this bucket up. So as this is turning around and around and around, this smaller axle is also spinning around. Well, the radius of this large turn is 150. And the radius of the small turn, the small axle, is 60. Well, again, effort arm over load arm is the same as radius of the wheel over radius of axle. So our wheel is here, so we have 150 divided by 60, right? So 150 divided by 60 gives us 2.5. So we know our mechanical advantage is 2.5. So again, mechanical advantage is how effective is the machine at increasing your force, making it easier for you. It increases the force that you've put in, right? You've already put in a certain amount of force. Well, mechanical advantage tells you how effective is the machine at using that force. So here, the mechanical advantage is 2.5. So the machine multiplies your force by 2.5. So we know what happens when the larger wheel is used to turn the smaller axle. But what advantage is there if you were to switch it? What if instead of using the big wheel as part of your effort, you switched it? Your effort is coming from your axle, the small wheel. What would happen then? Well, if you think about it, in our first example, our effort came from the wheel. And as this big wheel turned this large distance, sorry, that's not perfect, the small wheel moved a small distance, but rotated. So because you had a larger distance, you only needed a little bit of force. Well, if you use the small wheel and you apply the effort here, and you turn this small distance, you put this effort in the small distance, you turned the big wheel a large distance. What would be the advantage of that? So think about that for about a minute, because that is applied everywhere as well. Well, having the force applied to the axle makes the larger wheel turn. Well, since the wheel is larger, it goes further for each rotation of the axle. So when the axle turns, the axle only has, in this case, 1 inch. Let's say 1 inch, right? And when it turns all the way around, this one has a radius of 5 inches, so it moved even further around after one turn. Meaning that the amount of time it takes for this one to turn here, this distance, has to be the same for this larger distance, which means this big wheel needs to spin faster, right? Because they're attached. For this to turn once, this also needs to turn once. But because this is bigger, this needs to travel further. But for both of them to spin at the same rate, this one has to travel, or to rotate at the same rate, this needs to move faster. So the large wheel will turn faster. So an axle turning a larger wheel allows you to increase the distance, but you need to put more force into it. So it's the opposite. When you were turning the big wheel, you were increasing the distance you needed to move so that you could multiply your force. But if you're putting force into the small axle, well, you're increasing the distance you're moving. So you're moving faster. And this is exactly how cars work. So hopefully that was helpful, and I'll see you next lesson.